So everyone, welcome back. In this video we want to do example number 5 on page 469, and the question is: find an exponential function that passes through the points -2, 6, and the other point is 2, 1, and the function is supposed to be exponential. So I want to find the exponential function that passes through these 2 points. Now, basically, what is an exponential function? It is f of x is equal to a times b raised to the power x. So based on these 2 points, you're supposed to find an equation for this function. So what you can do is, since you have the 2 points, you can write a few equations based on this. For example, since you have, for example, -2, 6, you can write, based on this and the general form of an exponential function, you can write f of x, which is 6 here, is equal to a, I don't know what a is, into b, I don't know what b is, but I know what x is. X is -2. So this means 6 is equal to a times b raised to the b raised to the power -2, means 1 over b squared. So basically 6 is equal to a over b squared. So you can call this, for example, equation 1. And also, since you have this point, for example, 2, 1, so 2, 1, you can write another equation like this. So you can write and of course, based on this, you can write your f of x, which is 1 here, is equal to a, I don't know what a is, I don't know what b is, but I know that x is equal to 2 here. So that basically means that a b squared is equal to 1. So this is equation number 2. Now, what you can do here is, you need to, basically you have these 2 equations, both of them, the unknowns in these 2 equations are both, in both cases a and b are unknown. But since you have 2 equations of the same type, you can figure out what a and b are. And what you can do is, from equation 1, for example, you can deduce that you can cross multiply. So you can put a 1 over here, so a into 1, which is a, is equal to 6 into b squared, or 6b squared. And so this is a in terms of b. Now in this equation number 2, you can substitute a with 6b squared. So then this equation becomes, instead of a, you simply write 6b squared. 6b squared times b squared is equal to 1. So that basically means that 6 into b raised to the power 4 is equal to 1, or b raised to the power 4 is equal to 1 by 6. So from here you can figure out what your b is. So the fourth root of b raised to the power 4, of course, is equal to the fourth root of 1 by 6. I've taken the fourth root of both sides of this equation. Now the fourth root of b raised to the power 4 is equal to b. And the fourth root of 1 by 6 is, I wish I had some way to show you my calculator. I don't. Let me see if I can. No, I can't. I'm sorry. But I think in the next videos, in the future videos, I'm going to turn on a Linux machine on this computer, and then I can show you a good calculator on a Linux machine. But for now, I just use my calculator here, but you cannot see it. Of course, you don't need to necessarily, but that would be nice if you could. So the fourth root of 1 divided by 6 is the fourth root of 1 divided by 6. So it just shows me some number, 0.638943142, but it's important. I mean, the number that the calculator shows me is 0.638943142, and of course it stops here. So there is no more digit that I can see. Of course, this is based on only so much my calculator can do, and it's of course based on the precision of the calculator and based on the settings of the calculator as well. So you need to know what sort of settings has your calculator been set to. For example, round to this number of decimal places, or do this to the decimal places, or rounded based off of this algorithm and things like that. So you need to understand your calculator, and you need to basically know how it's been programmed. And based on in different situations, you might even need to change the settings. Of course, you already understand that. And so now what I'm going to do, of course, I do understand that the number that's on my calculator screen like this is not the actual number, this is not the actual answer to the fourth root of 1 divided by 6. The fourth root of 1 divided by 6 can be approximated for as many digits after the decimal place as you want. But the calculator gives me just this sort of answer. Now, if I were to just round it up to, for example, 4 decimal places, I would simply write this as is approximately equal to, for example, 0.6389. 0.6389. But it's not a good idea to do that, because now based on this, basically this is my B here now. Based on this approximation, then I'm going to, for example, take this equation takes this equation, and based on this approximation of B, I'm going to calculate what A is. So then again, A becomes another approximation. So what I'm going to do is, I'm not going to round it up to 4 decimal places. I'm going to just, whatever the calculator has shown me, I'm going to save it to a memory in the calculator, and then use that memory content in the calculation later that I'm going to do for A. So for now, what I'm going to do is just save this. So on my calculator, it's Casio FX991ES. I just press Shift Store A, which I think I made a mistake. Let me do it again. Okay, so I saved the number to one of the memories in my calculator. I pressed Shift Store and the memory A on my calculator, and now this number, whatever that might be, I'm not interested in the number as it is right now. I store that in memory A in the calculator, and just for the sake of this, for here, I can basically write this approximation as b is equal to this number. So I can write this approximation as b is approximately equal to 0.6389 4 decimal places, and that would be enough for later. Okay, so so I'm going to erase this now. I don't need it. So what I'm going to do now is now I can take equation number 1 and calculate what a is, because now I know what b is. So a is equal to 6b squared. So a is equal to 6 times b squared, and I entered this equation in the same way into my calculator to I retrieve the value of b from the memory, square it. Of course, the whole thing is going to be done by the calculator, and then multiply that by 6, and that becomes a. So 6 times b squared, and let me have my calculator do it. And now my calculator gives me the number 2.4494 for a. So this is going to be of course this is going to be an approximation, not the actual value. And so now you know what your a is, you know what your b is, and so you can write down what your equation is. So we said that the equation for this function is going to be something like this: f of x is equal to a into b raised to power x. So we can write it as f of x is equal to a, which is 2.4494 times b, which is 0.6389 raised to the power x. And that is basically what you were looking for. And if you basically, for example, if you put x is equal to, I don't know, f of 2 here, f of 2 is equal to 2.4494 into 0.6389 raised to the second power, which is going to be, so my calculator gives me 0.999828448 284486, and that is basically, that is again an approximation, because the whole thing gets so complicated, and based off of some algorithm gives me this answer and rounds the number up to 6, 9, and 10 decimal places or something like that. So this is not exactly, because f of 2 is supposed to be equal to 1. Not exactly 1, but it's 0.99982 and so on and so forth. So basically, when what you're doing is critical, you need to understand your calculator and save things as much as possible, not round things up as much as it's possible, especially when you're in the middle of calculation. Don't round things up. When you're done, in the end, you can round things up if you need to, but in the middle, just you can save them to different memories and then retrieve the values from those memories and then reuse them in the rest of the process. So I hope you enjoyed this video. I'll see you in the next video.